This is chapter number 1, Chemistry of Representative Elements, that is part of inorganic chemistry, and the topic that we have today is the chemical behavior of halogens. Talking about the halogens, they belong to group 7A and includes the elements fluorine, chlorine, bromine, iodine, and acetylene. Their chemical behavior or reactivity can be determined by their bond enthalpies. By bond enthalpies, I mean their bond energies. And second is the ability of the halogens to undergo the redox reactions. The first topic that we will study is the bond enthalpies in halogens. Talking about bond enthalpy, it is the energy required for the dissociation of the halogen atoms in their gaseous state. It may vary according to the size of the halogen atoms, the bond length, and the intermolecular attraction. It means as the size of the halogen atom increases, eventually the bond length will increase and the intermolecular attractive forces will become weaker. This is a table. Here you can see that we have the halogens along with their atomic radius and bond enthalpies values. As we move down the group, the atomic radius is increasing. This increase of the atomic radius results in the weaker intermolecular attractive forces. Therefore, with increase in atomic radii, the bond enthalpy value will decrease. But you can see in the table that there is an exception for fluorine. The bond enthalpy value of fluorine shows an irregularity. So if there is an irregularity, there must be a scientific reason to explain it. For fluorine, due to the large repulsion between the non-bonding electrons and the small size of atom, we see these exceptions. Second, acidity of hydrogen halides. By acidity, we mean acid. And we know that acids are proton donor. Now, if you relate it with the strong acid, a strong acid is the one that completely dissociates, while the weaker one does not show complete dissociation. So, those acids which will release the proton directly, readily, they are considered as the strong acids. And which halogen will donate the proton? The one that has the smallest value of bond energy. So by the amount of little energy, it will donate the proton. This is an increasing trend in which you can see that the bond energy values are eventually what? They are decreasing from hydrogen fluoride to hydrogen iodide, which means that the hydrogen fluoride has the highest bond energy, hydrogen iodide has the lowest bond energy. Eventually, hydrogen iodide will readily donate the proton and it is the strongest acid among all these acids that are mentioned in the table. Next we have is strength of halogens as the oxidizing agent. What is an oxidizing agent? An oxidizing agent is the one that oxidizes the other species and itself get reduced. What makes them good oxidizing agent? First, they are high electronegativity values. Since they have high electronegativity values, so they readily accept the electrons. Here you can see that fluorine has the highest electronegativity value, so it is the strongest oxidizing agent, and as eventually the value of electronegativity is decreasing, the ability to accept the electron is also decreasing. So among all the halogen, fluorine is the strongest oxidizing agent. And why is that so? Because the highest electronegativity and has the smallest size. So eventually it will readily accept the electron and attain the negative charge. If you remember, the same reason we studied for the exception for the bond enthalpy as well. So you can easily relate both the scenario with each other. Next we have is halide ion as the reducing agent. For oxidizing agent, we got the concept of highest electronegativity. It means which halogen has the highest electronegativity will be the strongest oxidizing agent. So vice versa will be implemented for the reducing agent. The one that has the lowest electronegativity will be the strongest reducing agent. For oxidizing, it was accepting the electron. For reducing, it will donate the electron. So you can see that the relative strength of reducing agent is that iodide is the strongest. Then you have bromide, chloride, and the least we have fluoride, which shows little or almost negligible activity as the reducing agent, as it is the strongest oxidizing agent. Equations are also mentioned here, which shows that you can easily replace bromine and iodine by the chlorine. Same goes for the bromine, that it can be displaced with the iodine. The thing to keep in mind here is that fluorine is the strongest oxidizing agent, while as iodide is the strongest reducing agent. For fluorine, as it was strongest oxidizing agent, so here it is the weakest, and for iodine it is the strongest reducing agent. So for oxidizing it is the weakest. It is the vice versa of each other. How you get this question in your board examinations? You get it in 4 marks in your short as the scientific reasons. For example, they ask the acidity of hydrogen halides increases from HF to Hi. And why is that so? Because the bond enthalpy value is decreasing, so they readily donate the proton and shows acidity. And hydrogen iodide is the strongest acid. Similarly, fluorine is the strongest oxidizing agent. The variation in the bond enthalpy and role of halide ion as the reducing agent. There is one more topic that is related to this topic, that is the auto-oxidizing and reducing behavior of chlorine. Chlorine, when dissolved in water, itself reduces into hydrochloric acid and oxidizes into hypochlorous acid. This behavior is termed as the auto-oxidizing and reducing behavior of chlorine. This is the chemical equation. The easiest way to memorize is that in hypochlorous acid you have hypo, HO. So O means oxidize. Chlorine oxidizes into hypochlorous acid and reduces into hydrochloric acid. You also got this question in your board examination for 4 marks along with one more question as a part, which says explain the auto-oxidizing and reducing properties of chlorine. So you can write down the equation along with the explanation if they ask, and you will attain full marks. This is all for today. If you have any question regarding this topic, you can reach out. Thank you.